This problem will be the hardest problem on the test in my opinion, and it is a difficult problem. There are parts of this course that are difficult, and this is one of those parts. I started off by drawing the free body diagram here. It's a little confusing. Joint A is a ball and socket joint, so it has three reactions, RAX, RAY, and RAZ. But a ball and socket joint has no moments, so I didn't draw any moments in there. Next, I drew these cables coming out of point D, so here they are right here. TB, going from D to B, the tension towards B, and TC, going from D towards C, the tension towards C. Finally, you can see I put this uniformly distributed load. Its magnitude is 800 newtons for every meter, and it's 3 meters long, so 800 newtons per meter times 3 meters is 2,400 newtons total coming down. And of course, it's located at the center of the rectangle, which is in the middle, 1.5 meters over from that elbow joint. I knew I would need the unit vectors for these ropes coming out of point D, and so I went ahead and then found the unit vectors for the ropes. Walking from D to B, you go -1 in the X, -1.5 in the Y, and up 2 in the Z. And the length of 1 squared plus 1.5 squared plus 2 squared, all square root, is 2.693. And I went ahead and divided those out. So 1 divided by 2.693 is this, 0.3714. 1.5 over 2.693 is this, 0.5571. And finally, 2 over 2.693 is this, 0.7428. I then squared all of those, 0.3714 squared plus 0.5571 squared plus 0.7428 squared. I added them all up, and they did indeed add up to 1, and I was confident I got that right. I then noticed that the rope from D to C was exactly the same as the rope D to B, except the Y component was plus 1.5 instead of negative 1.5. So everything else is the same length, same X, same Z. And so I just used the numbers again. So it's minus 0.3714X, but it's now positive Y, so plus 0.5571, and it's the same Z. Then these kinds of problems, probably the easiest thing to do to start off is just add the X, Y, and Z forces. So I just looked at the free body diagram. I have the two tensions have an X component. I looked at the unit vectors, and they're both minus 0.3714. So minus 0.3714 tension B, minus 0.3714 tension C. And looking at the free body diagram again, there's also the X reaction at the ball and socket, RAX. That all adds up to 0. I called that equation 1. I did the same thing in the Y. Those cables also have a Y component, and they're opposite. So if you look at TB, its unit vector is minus 0.5571 in the Y direction times TB. And the tension to C is plus 0.5571, looking at that unit vector on the J component, times TC. And again, looking at the free body diagram, there's that Y reaction at the ball and socket joint. Again, all adding up to 0. I call that equation 2. I repeated the process for the Z direction. Looking at the free body diagram, you do have that 2,400 going down, that 2.4 kilonewtons or 2,400 newtons going down, so negative. And looking at the unit vectors, both tensions have a positive Z component of 0.7428. And don't forget to look at the ball and socket joint. That has a Z component as well. All these things add up to 0. I called that equation 3. I could then see that taking moments about the x-axis was going to be useful. I could see that if I took moments about the x-axis, the three reactions RAX, RAY, and RAZ all go through the origin right where the x-axis is, so they won't have moments. I also saw that that 2400 is pointing straight down right through the x-axis. That would not have a moment. And I knew that the two tensions would have a moment around the x-axis. Then I could visualize that the x component of these tensions is parallel to the x-axis, so that would have no moment. The z component of those two tensions, they're attached at D right over, vertically right over the x-axis. And so the z component, which points up and down, was also going right through the x-axis. That left the only component of the tension that's spinning around the x-axis were the y components, and they were pointing opposite of each other. So looking at the tension to B, the y component of tension B is spinning the whole arm around the x-axis in the positive sense. Your thumb points along x, and it's your fingers spin around that way. Tension B is pulling that way. So the y component of B was 0.5571. The vertical distance to D, where that tension's connected, is 1 meter. And again, it's positive, going in the positive direction around X. The tension to C is pulling in the opposite direction, and it's flipping that blue arm towards you out of the paper, and that's spinning around the negative axis. It has the same y component, 0.5571, the same vertical distance from the x-axis to D of 1, and it is spinning the other way, so minus. And when I looked at that equation, you could cancel out the 1s, you could cancel out the 0.5571s, and you get that TB equals TC. And so I just gave them both the letter T. So anywhere you see TB or TC in any of the equations, you can just substitute C. Next, I could visualize this arm looking down the y-axis, and so I wanted to take moments about the y-axis, spinning around the y-axis. And so what I've drawn here is this picture looking straight down the y-axis, so you're seeing the z and x-axes, but you can't see the y-axis because it's coming right out of the paper at you. Okay, the y-axis is coming out of the paper at you. The first thing I noticed is that the drawing is wrong. I drew it to scale. That first joint, D, is at coordinates 1 and 1. But this elbow, which doesn't have a letter, it's 2.5 over, but its height is only 1.5. And so when you draw it, it looks like this. And actually, there's a bend there to get to this proper coordinate, and then it was horizontal from there on out. So that was a little surprising. The picture is drawn incorrectly. This is what it really looks like. Next, I put that 2,400 right in the middle of that 3 meters on the horizontal. So I drew that in there. And then what I did was the tensions. So there's 2 of these cables, but when you look on the side, they're right on top of each other. That's why I have times 2. That means there's 2 cables. There's one going towards B and one going towards C. But from the side view, because they're symmetric, they lie up right on top of each other. You can't see them separately. The Z component of both tensions, which we just said were the same, so I'm just using the letter T, is 0.7428. The X component is minus 0.3714, pointing in the negative X direction. And so all I've done is drawn the Z and X components of those cables, and I put times 2 to remind us that there's 2 of them in this view. So now I've turned it into a 2D problem. We're just going to take moments about this point right here. This is the y-axis point. And so you have that 2,400. Its perpendicular distance from the origin there's 2.5 meters to the end of it, and another 1.5 meters to the middle of it, and so you get a total moment arm of that times 2,400. Okay, that's spinning positive around the origin. That 0.7428 Z component, it's spinning clockwise around the origin, so negative. There's the force. Its perpendicular distance is 1 meter. And don't forget there's 2 cables, so I said multiply it by 2. Next, I looked at the x component. It's 0.3714 t. Its perpendicular distance around the origin happens to also be 1. And don't forget there's 2 cables, so I multiply by 2. And then I immediately just solved that equation for t, and I got 4,310 newtons, actually 4308.02. I kept all the decimal points, and when I put that exactly into equation 1, it came out to exactly 3,200 for RAX. When I put that into equation 2, you can see that TB and TC cancel out. That makes RAY 0. And then finally, I put that into equation 3. And when I did it all out, it came out to exactly minus 4,000. So actually going in the negative Z direction. Again, this will be the hardest problem on this test, and maybe of all the tests in this course. Yeah, this is a little bit difficult, and it will be challenging. Now, if you can't see these side views and what I did, you can still just do R cross F dot U to get the moment about the y-axis, and it'll all work out, but it'll make the problem pretty long if you do it like that.